This project shows an exemplar application of a robotics project in a science classroom. This would be an open-ended topic. The kids get to choose their topic mid-unit and build something. I'm showing convection currents, continental drift, fossil evidence of continental drift, and plate tectonics. I decided to use the Hummingbird Premium Bit Kit as the basics of the robotics for this project. Once I figured how to wire it properly, it was very easy to apply the wires to the device. I was pleasantly surprised with that. I put together a gearbox because the motor just simply wasn't strong enough. I needed the gear ratios in order to make the pulley work. Once we got going with that, I did finally get a final product put together. I got it decorated. I now have a pulley system that exhibits all the things that I wanted the kids to see mounted to cardboard, and it's quite sturdy. Students try to understand SNAP and work their way through it will definitely be a struggle for them. I do look forward to seeing what they might be able to accomplish, but they're definitely going to need some help learning. All right, so I tried to make this as simple as possible. I also kind of thought about this as encouraging kids. Let's make it a museum piece where a kid will walk up and will say, oh, what does this do? And push a button and watch what happens. Right, so that's what I tried to do. I tried to make something that would reset itself so it could just be used over and over. So, with that said, I'll narrate a little bit because I'm not sure how much you can see. There's a start button, and it does say millions of years ago, right? Plate tectonics simulation. Okay, so it says Pangea. Types that out, and see the lights are those colors that I kind of mentioned. And as you watch, it's going to count down the time from the past in millions of years until we get to the present day approximation. And again, the gear ratios make it a little bit slower than I wanted. However, it functions and it's strong. At a certain point, it will stop and reset itself. And mention it counts down those millions of years. Now it says today, right? Then it all kind of shuts down and resets itself, and then it's ready for the next person to push the button. So, is there someone who would like to come press the button after this resets?
I'll press it.
All right. Yes. Doesn't require a lot of skill to operate. Hopefully that was my main goal here. Yeah. I had considered putting these upright so it could be viewed this way, but then I thought that doesn't represent how the tectonic plates would drag laterally as well. Perpendicular motion.
Well, it kind of represents the model of the Earth, right? You know,
Exactly, yeah.
That horizontal view.
You know, for future iterations, something that I would have considered doing would, place this up higher and have like the core of the Earth kind of displayed down lower. Just anything that could add details to it. So, if you like, the start button is that little button right on the front there, where it says start. Saying, it says Pangea, you got it. And off it goes again. First version of the code I had to reset it by hand every time, and yeah, it's not so easy, but I figured out some code where I could just use variables to say how long I wanted to move, and then that would calculate the colors for me, and then change the colors over time. I don't like the green that's in there. I'd rather it was red, yellow, blue. But that's be an improvement that I could encourage students to make as well on their projects.